questions 21 through 25 on the 2013 Grade 10 Cayley Math Contest. In the addition shown, the letters X, Y, and Z each represent a different non-zero digit. The digit X is. You go back to your basic days of learning how to add, and from that, you will be able to understand that X plus Y plus Z is equal to X. But it's not quite that simple, right? Because if that was true, just like that, that means Y and Z would have to be 0. And they already told you that they're not 0. Okay, so well then, how do I do this then? Well, it basically means that you had a carry. So I'll give you a simple example. Let's say if X was 3, and then Y was 8, and Z was 2, it would be 13. So it would still be a 3, but then you'd carry the 1, right? That's basically what that means. So instead of this X, it's really 10 plus X. That's how you get a carry. Okay, that takes care of this guy. And remember, I carried a 1, so put a 1 up there. And then look at the next column. For my next relationship, that'd be 1 plus X plus Y plus Z is equal to Y. But again, as I clearly, I hope, explained before, it's not going to be Y, it's going to be 10 plus Y. Because again, we're going to have a carry. Because otherwise, it wouldn't make sense. So again, we're going to have a carry like that. And then now, if you look at this column, it would be 1 plus X plus Y plus Z is equal to, well, now you got to think, what's going on here? Well, it's basically just 10Z plus Y, because that's all that's left. And the Y is representing sort of a digit, but the Z, you have to multiply by 10, because it's something like 25. So it'd be 2 times 10 plus 5, like that. So here we go. These are my system. These are my equations. This is my system of equations. And now I just got to fiddle around with this to figure out what is the value of X, Y, and Z. Okay, here we go. So where do I want to begin? Let's see here. It's tempting to put this here, so let's do that. So instead of this, I'm going to put 10 plus X, because that's what it's equivalent to. So I got 1 plus 10 plus X is equal to 10 plus Y. Correct? So that basically means that 1 plus X is equal to Y. Okay, that's a pretty good result. Let's see, where do I go from here now? I'm going to substitute those findings into this guy here. So this gives me 1 plus this, which is 10 plus X. So 1 plus 10 plus X is 10Z plus Y. 10Z plus Y, but Y is 1 plus X. Let's put that in there, 1 plus X. And now 10 is equal to 10Z, and therefore Z is equal to 1. Great. I've got one of the letters. And I guess now I can just substitute it back in, now that I have Z. I can put Z back into any of these and proceed from there. So let's just substitute it into there. That's pretty straightforward. So that would become X plus Y plus 1 is 10 plus X, and therefore Y is equal to 9. Okay, perfect. And now I just have to substitute into somewhere to get a value for X. Again, I think I probably just use the same one. Might as well. Or actually, no, just put it in here. Makes it easy. I already figured out something between a relationship between X and Y. 1 plus X is Y, so 1 plus X is equal to 9. Therefore, X is equal to 8. And there you go. Okay, and just to be on the safe side, let's just see what happens. 8, 8, 8, 9, 9, 9, 1, 1, 1. Okay. 18, carry the 1. 19, carry the 1. And 19. And yeah, it all matches out exactly like that. So X is equal to 8, and therefore number 21, the answer is D. In the diagram, PQRS is a rectangle, point T is outside the rectangle, so that angle or triangle PTQ is isosceles and right-angled. Hypotenuse is PQ. If PQ is 4, QR is 3, then the area of PTR. Okay. Well, lots of ways of doing this question, actually. There's several sort of approaches. I'm going to use the approach that I like best, is I'm going to put it on a coordinate axis. All right, let's divide this into different regions. So this is going to be A, this will be B, C, D, and E. Okay, and let's label this. PQ was 4, and then QR is 3. So it's a rectangle, right? So that means this is 3 and that's 4 also. Okay, so what do they want? PTR. Triangle PTR is what they want. All right, and PTR, according to my labeling, is B plus D. So I have to somehow figure out what is B plus D. I think I can do that. Well, first and foremost, what is A plus B? That is very easy to figure out. That makes a triangle, and the triangle is 1/2 base times height. The base is top to bottom there, which is 4. And the height is going to be the distance from here to here. Okay? Now, I'm not sure what that is, but there's another way to figure it out, and that's this clue right there, that PTQ is an isosceles triangle. So if it's isosceles, that means this and that are the same. So let's just call those x. Okay? So that means x squared plus x squared is equal to 4 squared. And the reason I know I can do that is because they told me it's right angled. So that's obviously a right angle right there. So that means 2x squared is 16. That means x squared is 8. And therefore x is root 8. So in order to figure out the area of that triangle, I can just use pretty much this as the height and this as the base. Either way, it will give me the answer. So 1/2 root 8 times root 8. And therefore, that is going to be 4. So that is A plus B. Now let's concentrate on these guys, C, D, and E, that make up that rectangle. And that's going to be very straightforward. The area is going to be just 3 times 4 because those dimensions have been given, and that's 12. Okay? So we have to now isolate from all this B plus D. Okay? So let's see here. A plus B plus C plus D plus E, all of this. Well, A plus B I just got was 4. And C plus D plus E I got was 12. So this whole thing is 16. Now, I'm not interested in all that. I'm interested in just B and D. If I can get that sum, I'm done with my question. So I'll put that out here. B plus D, I'll separate it. And then all I've got left was A plus C plus E. Correct? And that's 16. Okay, well, E I think is the easiest of those. That's just going to be 1/2 base times height with those dimensions. And then B plus D, that's my triangle PTR, I should say. And now all I have to do is figure out A and C, and then that should be it. But A and C are not as easy. We have to figure out this point right here. And that's why I put it on the coordinate axis. It's actually not that difficult. You might think, oh, geez, that's a lot of work. It's actually not. It's pretty straightforward, and I'll explain why. So what I'm interested in now is just to figure out the equation of that line. If I can figure out the equation of that line, and I have this point right here, I can figure out these two triangles without any problem. Well, first of all, let's figure out what is the distance from here to here. Well, if I draw a little line from there to there like that, that's obviously going to be a right angle, and that makes this a situation where this triangle, which is isosceles, I have essentially just cut it in half. So that line would divide that base into equal parts, correct? So that means this would be 2 and this would be 2. So I can put that in. I'll just put the 2 right here. But notice this was isosceles right here, and this was 90. So that means that this angle is 45 degrees. Now, if you look at just this triangle, then that means that this angle is 45 degrees. This one right here. Well, therefore this is isosceles again. So that means if this is 2, then this is 2 right here. So that's basically going to be 2 right there. So this is 2, the distance from the origin to P. Okay, so once I find the equation of this line, all I have to do is just plug in x equals 2, and that will give me the y coordinate of that point. So already I know that's 2 for the x coordinate. I just want to find the y coordinate. Okay, how do I figure out the equation of line TR? Well, it's y is equal to mx plus b, like all lines, but I've got 2 points on there. This first point right up here is going to be 5, 4, right? It's 5 going that way and then 4 going up there. And then this point right here, that's pretty straightforward. That's going to be 0 and 2 for the y coordinate, because remember we're going up 2. 2 points, that's all you need to figure out the equation of a line. So here we go. Sub in 0, 2, and you get 2 is equal to b. Sub in 5, 4, and you get 4 is equal to 5m, but b is 2. So that means 2 is equal to 5m, and therefore m is equal to 2 over 5. And there we go, we just got the equation. Y is equal to 2 over 5x plus 2. And now all I have to do is plug in x equals 2 to figure out my y coordinate. And when I do, I get 2 times 2, which is 4 over 5 plus 2. And that is 2.8. Okay, so from here to here is 2.8. And therefore from here to here will be 4 minus 2.8, which is 1.2, correct? Yeah, 1.2. All right, that's all I need to figure out A and C now, going back to the question. A is going to be 1/2 base times height. The base is 1.2, and the height is from here to here, which is 2. And then C, again, 1/2 base times height on that triangle. So that's 1/2 base, which is 3, and the height is 1.2. Okay, I've got it all here. Let's figure this out now. Triangle PTR plus, that looks like 1.2 plus 1.8 plus 1/2 times 12, so 6 is equal to 16. So triangle PTR is 10 minus 3, which is 7. There you go. Number 22, the answer is 7, which is choice C. One bag contains 2 red marbles and 2 blue marbles. A second bag contains 2 red marbles, 2 blue marbles, and G green marbles. G is greater than 0. For each bag, Maria calculates the probability of randomly drawing 2 marbles of the same color in 2 draws from the bag without replacement. Drawing 2 marbles without replacement means drawing 2 marbles one after the other without putting the first marble back into the bag. If these 2 probabilities are equal, then the value of G is. All right, well, let's figure out both scenarios, and then once we do, we are going to equate them, and then in the end, we will figure out the equation. So here we go. So the first scenario is you got 2 red and 2 blue, and what they want you to figure out is what's the probability that if you choose 2, you're going to get 2 of the same color. Well, if you want 2R, from these initial 4, you've got to choose an R. So the probability of choosing an R initially is 2 out of 4. That's the first selection. Then you have to multiply that by the probability of choosing another R for the second selection. Once that first R is gone, now you only have 3 left. So the probability of getting an R from those 3 would be 1 out of 3. So it's 2 out of 12, the probability of getting 2R. In a very similar way, the probability of getting 2b, 2 out of 4 originally, the probability of choosing 1b for the first selection. And then once that's gone, the probability of choosing a b from those 3 is 1 out of 3. Identical to the same one that we did previously. So that's the probability of getting 2b. Now we have to add them because they want a scenario where you have just the same color, not necessarily only R or only B. Okay, no problem. 2 over 12 plus 2 over 12 is 4 over 12, and that is 1/3. So this is my probability. Now the probability here, they're saying, is got to be also 1/3. This second scenario. The second scenario is where you have, again, I believe, 2 blue, and you have 2 red. But then you have a whole bunch of G's, and they don't tell me how many G's. They say G, certain number of G's. And the number of G's is G, small g. So there's 2 reds, obviously. There's 2 blues, but they only tell me that there's GG's. Okay, no problem. It's the same story, really. There really isn't much of a trick. It's just the same pattern as we did over here. So here we go. The probability of getting 2R, the probability of getting 2B, and the probability of getting 2G. We want to ensure that when we draw 2, they're the same color. Okay, for 2G, well, actually, let's do R first, of course. The probability of getting the first R is going to be 2 over all of these. So that's 2 plus 2 plus G, which is 4 plus G. Then the probability of getting another R would be 1 over, now we'll have only 1 plus 2 plus G, which is 3 plus G. Okay, so I want to ensure that that has been explained properly, and I hope it has. So this is just 2 over 4 plus G times 3 plus G. Okay, for 2B, pretty much the exact same thing. The probability of getting the first B would be 2 over 2 plus 2 plus G, which is 4 plus G. Actually, I think I might have caused a little bit of confusion because I'm using capital G. And here I put small g. So I don't know if that caused any confusion or not, but let's just put small g just to ensure that no confusion is caused, that small g represents the number of green marbles. Okay, moving along, it's the same thing. The second selection will be 1 over. This time there's 1 less. So it's 1 plus 2 plus G, 3 plus G. And that product remains the identical as before. Now we get into the probability of getting 2 greens. Okay, probability of getting the first green is G over the total, which would be 2 plus 2 plus G, which is 4 plus G. The probability of getting a green for the second selection, now we have only G minus 1, because 1's already gone, over 2 plus 2 plus G minus 1. So that's going to be 3 plus G. And therefore that's G times G minus 1 over 4 plus G times 3 plus G. All right, so now what we have to do, we have to add these guys, and we have to equate it to 1/3, because the probability, the total probability, is 1/3. They've told me that the probability is the same in both scenarios. All right, the denominator is the same, so I can just write them all. 2 plus G times G minus 1 all over 4 plus G times 3 plus G is equal to 1/3. All right, this is what we have to solve. So here we go. So we got 4 plus G squared minus G, and of course let's just cross multiply, and then cross multiply those guys, and we get 12 plus 4G plus 3G plus G squared. And this looks like 12 plus 3G squared minus 3G is equal to 12 plus 7G plus G squared. 12's cancel on both sides. Let's put everything on one side. And when I do, I'll get, let's see here, 2G squared minus 10G and I think that's it, right? Yeah, equals 0. Okay, factor out a g, factor out a 2, and I'll get g minus 5. So g is either equal to 0 or 5. They told me in the question that g is greater than 0, so therefore g is 5. And therefore number 23, the answer is B. A cone is filled with water. Two solid spheres are placed in the cone as shown in the diagram, and water spills out. The spheres are touching each other. Each sphere touches the cone all of the way around, and the top of the top sphere is level with the top of the cone. The larger sphere has a radius twice that of the smaller sphere. If the volume of the water remaining in the cone is 2016 pi, what is the radius of the smaller sphere? The volume of a sphere with radius r is 4/3 pi r cubed. The volume of a cone with radius r and height h is 1/3 pi r squared h. We must label this diagram, and here we go. I will label it A, B, C, and then we'll call the center O, we'll call this center Q, and the very bottom we'll call P. Now, this, from here to here, AC, represents the radius of the cone. So I'll just write RC there. This is the radius of that small sphere. We'll just call it R, obviously. And these guys are the radius of, or the radii, I should say, of the large sphere. And they told me that the large sphere, the radius is twice of the smaller sphere. So I can just write 2R right here and 2R. And these are 90 degrees, just in case you cannot see that. That's 90 and that's 90. Why? Because those are tangent lines. They touch the other line, and if it's tangent, it will create a 90-degree angle. And this is also a radii, so that's also 2R. And I think that's pretty decent labeling for now, so let's move ahead with the question. The first step in this question is to understand that we have a similar triangles relationship. And those similar triangles are triangle OTP being similar to triangle QUP. So OTP, this is T and this is U. So OTP is this triangle right here, and that's similar to QUP, and I hope you can see that. They're pretty much got the exact same angles. So based on that, OT over QU is the same as OP over QP. Well, OT is 2R and QU is R, and that's the same as OP over QP. So that basically means when the R's cancel out, that 2QP is equal to OP. All right, so that is very helpful, and that allows us to get a relationship between the height, which is the top to bottom, that's the height, H, of the cone, to R, and that's pretty much going to be what we need to solve this. All right, well, OP, which is the distance basically from here all the way down to there, is equal to OQ from here to here plus QP from there to there. So OQ plus QP. And OQ from here to here is 3R. It's this guy plus this guy. So that's 3R right there. So put that in here, 3R. And then QP, well, QP I don't know yet. So I'll just leave it there for now. But I know this relationship, that 2QP is equal to OP. So that's very helpful. So instead of this OP, I'll just put in 2QP. So there we go. 2QP is equal to 3R plus QP. And then if you put 1 QP on the other side, we get just QP is equal to 3R. So there we go. That's a very helpful finding, that the distance from Q to P is 3R. So I'll just put that in here, 3R. And then also we know that 2QP is equal to OP. So that means 2 times QP is equal to 6R, and that's equal to OP. So that is OP. So those are two very important findings. Now, what's H? The height of the cone. Well, the height of the cone is all the way from C down to P. Okay, let's count now. 2R, 2R, that's 4, 5, plus 3, 8. So the height is 8R. So those are very, very important findings. And now we can proceed with the second part of the question. The second part involves getting the radius of the cone in some sort of a relationship with R, something. So that is what we have to do. Because here we got the height in terms of R. So we have to now get the radius of the cone in terms of R. And once we have those two things, we can solve the question. Well, to do that, we have to use another similar triangles relationship. This time the triangles are ACP and OTP, a triangle that we had already looked at. So let's look at that now. Where is ACP here? ACP, so all of that big guy right there, that's one triangle. And then OTP is this one, OTP. Those are similar triangles because they share the same angles. So that basically means that AC over OT is equal to CP over TP is equal to AP over OP. All right, so let's label in AC is RC, the radius of the cone. OT, do I know anything about? Yeah, it's 2R. Okay, great. CP, that's the height, remember? And the height, I already figured out a relationship, so that's 8R. TP, do I have anything? TP, I don't really have anything yet. Okay, so I'll just leave TP for now. AP, again, I don't think I have anything for AP just quite yet. So I'll just put in AP for now. And then OP, now that one I have from O down to P, that's going to be 2 plus 1 plus 3, and that's 6R. Okay, so that's a pretty good set of findings. However, I'm going to need to know the value of TP in order to really figure this out. And that's not a problem because I can use Pythagoras. I can use Pythagoras on that triangle right there to figure out TP. So TP squared plus TO squared is equal to OP squared. So that means TP squared plus TO, what is that, 2R squared is equal to OP squared. And OP was what, 6R, right? So there we go. So that means TP squared is 36R squared minus 4R squared. So that's 32R squared is TP squared. So TP is going to be root 32. So what's that, 4 root 2? 4 root 2R. Okay, great. So now we can go back and use that relationship. So RC over 2R is equal to 8R over TP, which is 4 root 2R. Okay, so that means RC is equal to 16 over 4 root 2R. And that, of course, that simplifies to 4 over root 2R. All right, great. Exactly what I needed. RC in terms of R. So now that we have this relationship and we have this relationship, we can now solve the question. So here we go. If you were to interpret the question correctly, you would write the following: that the volume of the first sphere and adding to that the volume of the second sphere plus the volume of water, which they had said is 216 pi, equals the volume of the cone, right? because you have the volume of the first big sphere, the volume of the second sphere, and all the water that's been, filling the other parts. That all combined equals the volume of the cone. So that is how we're going to proceed with this question. Now, they are very helpful by giving us some formulas. The first volume is 4/3 pi r cubed plus 4/3 pi small r cubed, and then just 2016 pi, and then the volume of a cone is 1/3 pi radius of the cone squared times the height. Okay, the first thing we can do is eliminate all the pi's, so all these pi's can go. And then we can multiply through by 3. Multiply through by 3, and that will get rid of the fractions. So when you do all that, you will get 4r cubed plus 4 small r cubed plus 6048. Remember, I'm multiplying through by 3. And this gives me just rc squared h. Okay, great. Now all I have to do is substitute everything in. So when I do that, this big R, remember, was twice small r. And then this is just 4r cubed. This is 6048. Now RC, in a very helpful way, I got it in terms of small r. So that's going to be 4 over root 2 r all squared. And then h, again, I got in terms of small r. So that's going to be 8r. All right, I only have one variable. I can solve this. So 2 to the power of 3 is 8. 8 times 4 is 32. So that's 32r cubed plus 4r cubed plus 6048. This is going to be, let's see here, 4 times 4 is 16 over root 2 squared is 2. So 16 over 2 is going to be 8. So 8r squared. And then times 8r. Okay, so this is 36r cubed plus 6048, and this is 64r cubed. Bring the 36 over. 64 minus 36 is 28r cubed over, and that's equal to 6048. 6048 divided by 28 is 216. And then if you take the cube root, you get r is equal to 6. And there you go. That's the radius of the small circle, and that is what they wanted us to figure out. What is the radius of the smaller sphere, I should say, not circle? So number 24, the answer is B. A positive integer has k trailing zeros if its last k digits are all 0, and it has a non-zero digit immediately to the left of these k zeros. For example, the number 1030000 has 4 trailing zeros. Define z at m to be the number of trailing zeros of the positive integer m. Lloyd is bored one day, so makes a list of the value of n minus z at n factorial for each integer n from 100 to 10,000 inclusive. How many integers appear in his list at least 3 times? Note, if n is a positive integer, the symbol n factorial is used to represent the product of the integers from 1 to n. That is, n factorial equals n times n minus 1 times n minus 2 all the way down to 1. Okay, so let's make a table and let's explain this question. Let's start with the smallest number, which is 100. We've got n, and then we've got this n minus z to the n factorial. And we've got to figure out what this is. So 100 minus z to the n factorial. Okay, so what does that mean, z to the n factorial? Well, basically what you have to do is figure out how many times this number has factors of 10. And what I'll do is I'll explain that first, and then I'll come back to the table instead of just filling out the table. So for example, if z to the power of 100 is what I have to figure out, well, that's pretty straightforward. There's only 2 factors of 10, right? Because 100 is basically 10 times 10. So this is equal to 2. But what if I had z times 100 times 99 times 98 times 97 times 96 times 95? What is that? How many zeros are at the end? Well, you can do that in a calculator, but I'll show you an easier way. You have to figure out the number of factors of 10. Now, keep in mind that 10 is equal to 2 times 5. So really what you only have to do is figure out how many are factors of 5. Well, that is divisible, obviously, by 5. It's divisible by 10. It's 10 times 10. This is not divisible by 5. Neither is this, neither is this, neither is this, but this is. So that's going to give you another 5. And then you're going to be able to squeeze out a 2 from any nearby or adjacent even number. So you squeeze out a 2. And there you go. 2 times 5 equals 10. So this 10 is this 10 give me 3 trailing zeros, right? Because that would 10 times 10 times 10 would basically be 1,000. And that's what I mean by 3 trailing zeros. So this whole guy is 3. See what I mean? So let me show you the 100 factorial. Now, at first it might seem a bit daunting, right? But trust me, if you understand it, it's actually not so bad. This is what you do. You take this 100 and first of all understand that it's 100 times 99 all the way, right? I'm certainly not going to write it all out. Dot, 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 all the way down to 1. Now, all those numbers, we have to figure out how many times do we have factors of 5, just as I did over there. And this is how you do it. You take the number 100 and you divide by 5. And then, of course, you want the integer value, and that's what that symbol means. But here's the thing. All of those numbers from 1 to 100, I wanted to figure out how many of them are divisible by 5. That's fine. That's what this is. But also, I have to figure out how many of them are divisible by 25, because that's also going to give me factors of 5. Okay, so that's a key thing there. And then I have to figure out how many give me factors of 5 when I divide by the next multiple, which is 125. But in this case, it's not necessary because that's going to be 0, basically, because 100 is smaller than 125. So I don't need to worry about that right now. But I do need to concentrate on these two. This is 20 and this is 4. So that means there's 24 factors of 5. And for each of those, you'll be able to get a 2 from an adjacent number. Getting 2s is not a problem. There's lots of 2s, right? Because the multiples of 5 happen every 5th, but the multiples of 2 happen every other. So there's always going to be multiples of 2 to match with the multiples of 5. So what that 24 really means is that this z100 factorial is some number, I don't know, some big long number, multiplied by 5 to the power of 24. And like I had previously mentioned, you're always going to be able to get some 2s. And this will be 10 to the power of 24. It'll be some big long number multiplied by 10 to the power of 24. So that's 24 leading zeros. So therefore this is 24. See how that works there? I'll do one more, and I hope by that point you'll get the hang of it. Let's do a big one. Let's do 5,000. 5,000 factorial. Okay. So how do you do that? Well, 5,000. Of all the numbers from 1 to 5,000, how many are divisible by 5? That gives me that answer. Then I also have to figure out how many are divisible by 25. That's going to give me factors of 5. Then I have to figure out how many of those are factors of 5 by dividing by 125. Then also 5,000 divided by 625, which is 5 to the power of 4. And then 5,000 divided by the next factor, which is 5 to the power of 5. And that is, of course, 3125. So 5,000 divided by 5, of course, is 1,000. 5,000 divided by 25 is 200. 5,000 divided by 125 is 40. 5,000 divided by 625 is 8. And 5,000 divided by 3125, the integer value will just give me 1. So that's what? 1249. So z to the 5,000 factorial is 1249. Because what I calculated here is the number of times I can squeeze out a 5. How many factors of 5? How many times does 5 go into these numbers? And then for each of those, there's always going to be a matching 2. So it's really 2 to the power of 149 times 5 to the power of 1249. And that is, of course, 10 to the power of 1249. So this number, this huge number, is really some big, long bunch of numbers, I don't know what they are, multiplied by 10 to the power of 1249. And the fact that it's 10 to the power of 1249 gives me the conclusion that there are 1249 trailing zeros. It's some big, long number with 0, 0, 0, 0, and there's 1249 zeros. So I sincerely hope you understand that. If so, let's go back to the table and let's figure this out. So we're going to need this whole table here, so let's make it as large as possible. Well, just as before, to get the value, I have to divide by 5, and I've also got to divide by 25. And this gives me 20 plus 4, and that's 24. So z to the n factorial, when n is 100, is 24. So there we go. And that gives me 76. So that's the very first value that I figured out for my table. Let's do just a couple more. Let's do 105, and then we'll go up to the bigger numbers. Same way, 105 divided by 5, and then 105 divided by 25. And this gives me 21 plus 4, and that's 25. So this is 105 minus 25, and that is 80. Okay. And as you can see, that's what we're going to do. We're going to be figuring out these numbers. Now, what they're saying is that they want you to figure out when you get the same number happening 3 times. So far I got a 76, I got an 80, right? All right, let's experiment with this a little bit. Somehow I think that once you hover around the multiples of 5, you're going to get the same values. So if you remember, the multiples of 5 were 5, 125, 625, and 3125, right? And I'm pretty sure that's going to be, because you'll see when I do it what happens. There's a certain aspect of this question that allows you to get the same value. So let's jump to the first one, which is, it's not 5, it's not 25. We start at 100, so the very first multiple is 125. Okay, let's start with 125. And let's see what happens. So this is going to be 125 divided by 5 plus 125 divided by 25 plus 125 divided by 125. Well, that is 25 plus 5 plus 1. So that's 31. So this n minus z to the n is basically 125 minus 31. And that is equal to 94. All right, let's do the same thing for 126. And if I do that, I'll spare you the math there. That's going to be 126. And this calculation will be pretty much the same. It'll be 31 again. So that will be 95. All right. And let's do one more, 127. That will be 127 again minus 31, which is 96. Okay, we're going up, so obviously we're not going to get the same value. But let's say if we went backwards, 124, what would happen? Well, it would be 124 over 5 plus 124 over 25. And then the 124 over 125 we don't need to do because that's less than 1. This is 124 divided by 5, the integer value, is 24. And then 124 divided by 5, the integer value is 4. So that's 28. So it's 124 minus 28. And that is equal to 96. Well, here we go. This is the first time in the question we got anything that remotely approaches what we want. We got two values that are the same. That's good. But what we want in the question is 3 times that the same integer appears. So this scenario is sort of a start. This is good. Same integer appears twice. We want a scenario where the same integer appears 3 times. Okay. So I hope at this point in the question you're kind of getting an idea. And since I hovered around that 125, let's hover around the 625, which is the next multiple of 5, and see what happens. All right, so I will just do the first one, and then I'll let you do all the other ones, but I'll walk you through it, of course. So I've got to figure out, again, this whole thing, right? So 625 divided by 5, 625 divided by 25, 625 divided by 125, and then of course 625 divided by 625. So this is going to give me how many times 5 is a factor, and that represents how many times 10 is a factor. Well, 625 divided by 5 is 125, and then the next one is 25, the next one is 5, and the next one is 1. So that is what, 156. So it's 625 minus 156, and that is equal to 469. Okay, and I will let you do this part for all these other guys, and I'll just fill in the numbers. When you do, for 624, you end up getting 472. For 626, you get 470, and then 471 for 627, and then you get 472 for 628. So again, we got the same value twice. But twice is not good enough. We need the same value 3 times. All right. Okay. Let's keep going. And I have a feeling that since we're running out of powers of 5, it's got to happen when it's 3125. That's the highest power of 5 because our upper limit is 10,000. We can't go to 5 to the power of 6 because that would be outside of the range. Okay, so let's do this range. All right, so this part over here, I will only do, I'll do it twice, okay, because I think you will be able to do it on your own. So 3125, I'm going to be very interested in knowing that one. Well, it's 3125 minus this z to the n factorial. How do you figure that out? Well, 3125 divided by 5, that integer value, plus 3125 divided by 25, that integer value, plus 3125 divided by 125, plus 3125 divided by 625, and finally plus 3125 divided by 3125. Okay, well, this is it says 625 plus 125 plus 25 plus 5 plus 1, and that is 781. So this is 781, and that is equal to 3125 minus 781 is 2344. 2344. Okay, so I think this part you're an expert on. You certainly don't need me to walk you through every single number. That would be just painful. I think you can figure it out. You're doing pretty much the same thing. The only difference is instead of putting in a 3125, you'd put in a 3124, and then you'd put in a 3123, and then so on. So when you do that, you subtract from these numbers, these are the numbers that you get. 3119 minus this whole thing for 3119, it comes out to 775. And that is 2344. All right. And then when you do it for 3120, when you do this whole thing, it comes out to 776. So that gives me 2344. Yeah. And then I'll just fill in the other ones. This is 2345. This is 2346. This is 2347. And this one is 2348. And then for 3126, it becomes 2345. And then it's 2346. 2347. And then 3129, it was basically 3129 minus z at n, and that if you did this whole thing for 3129, I'll just give you the number. It's 781 again. So that basically came out to 2348. And then if you do the same thing, it's 2348 for this also. Why? Because when you do this whole thing for 3130, it actually gives you 782. So this becomes 3130 minus 782. And that is 2348. And then this one gives you 2349. Okay, so now we're in business. Because as you probably have seen, the same number appears this time 3 times. 2344 appears once, twice, and 3 times. There we go. And then there's another one that appears 3 times. It's 2348. 2348 appeared once. 2348 appeared twice. And one more time up here. There we go. So 2 numbers appeared 3 times. 2344 and 2348. Both appeared 3 times. The question is asking how many numbers appear 3 times. So far we found 2. Well, I don't want to torture you by doing this again. I did it for 3125. The good news is the next number that it works for is 3125 times 2. And the next number that you get the same scenario is 3125 times 3. Basically multiples of 3125. For this guy, very similar. You will get 2 integers that appear 3 times. So just like how I got 2 integers that appear 3 times, when you do the exact same thing for 3125 times 2, you'll get 2 integers. So you'll get 1 integer, we'll just call it n3 and n4. This is n1, let's say, and n2. And then if you do the same thing for 3125 times 3, again, you will get 2 integers. You'll get an n5 and an n6. And those will appear 3 times. Identical process to what I did right here. Nothing different. And you can do that in your spare time. Just like Lloyd, you can do it too. So how many do I get? I get 1, 2, 3, 4, 5, 6 integers that will appear 3 times each. And that is the answer to this very challenging question. Number 25, the answer is E.